It is the moment you've all been waiting for. We're actually going to start taking derivatives, finding what our slope functions are going to look like based on our graphs. So before we get into this big section with a bunch of rules and formulas, let's do a little exploration. We're not going to explore that many, but just a couple. If I have a constant function, what do you think the derivative is going to be? Constant functions look like this. They look like horizontal lines. The derivative of a constant function is going to be the slope. Well, no matter where I am on this line, what do you think the slope is? It's going to be 0. The derivative of a constant function is 0 because the slope of a constant function is 0. It's a flat line. All constant functions look the same. So derivative of constant functions, 0. What are the derivatives of any other line? Well, let's say I have the line 3x minus 5. What's the derivative of this line? The derivative is the slope. What's the slope of this line? It doesn't matter where you are. The slope of this line is going to be the same. That's something special about lines, right? The derivative of a line is just going to be whatever its m value is, whatever its slope is. Okay, so that's going to be m. And it won't depend on where we are. Now, what if I have some kind of function, maybe any function, and what if I multiply that function by a number? What if I multiply this function by 2? What's happening? It got stretched up. It's a little easier to see with the square root function. If I multiply this function by 2, it gets stretched. It's getting steeper everywhere. That last one's not as important. The idea is that remember that derivatives are just slope functions. Derivatives just tell us the slope of the original function at any place. So we've got a ton of formulas. We are not going to derive all of these. I'm not going to show you where all of these come from. We just need to be able to use them, okay? If you're curious, I'd love to talk to you about where they come from, okay? And I could show you some proofs. I could explain it away, but you don't need to know that. You could if you want. All you need to know is how to use them. So if I have if f and g are just some functions, remember that we can write the derivative like this. This says the derivative, right? The derivative of, that's what that means. The derivative of what's on the inside, and this means with respect to x. Which I feel like I have to explain my explanation. When I say with respect to x, that means x is our variable. Sometimes it's not always obvious what our variable is. We'll have different letters. X is the normal one. So the derivative of some constant, k, multiplied by some function, the k comes out inside. This is just that constant times the derivative of what the other function was. The sum and difference rule says that if I'm adding two functions together and I want to find their slope, the slope of two functions being added together is just their individual slopes together. We could see that with lines, right? If I have two lines, let's say I have one line, that's 2x minus 3, and another line that's like, I don't know, negative 5x plus 2. If I add these functions together, what are we going to get? Well, 2x plus negative 5x is negative 3x. If I add these two functions together, we get the pink one. The slope of the pink is just the slope of the blue, 2, plus the slope of the orange, negative 5. Resulting is negative 3. We can see that sum and difference rule in action. If I add two functions together, their slope is just added together. If I subtract two functions, their slope, their derivative, is just their individual derivatives subtracted together. This next one is well, there's a few big ones, but this is a really big one. It's called the power rule. We're going to be spending all of the next few videos doing examples. These are a lot easier to see with examples, I think. But this just says that the derivative of some monomial, the derivative of x raised to some number, is you bring down the exponent and then you subtract 1 from the exponent. So what this means is that the derivative of x to the 5th, that 5 comes down in front, and now the exponent is 1 smaller. We get 4. What that means is that the derivative of x squared, the 2 comes down, the exponent is 1 smaller. We usually don't write the 1 if x to the first power is just the same as x. And this works with negative exponents too, right? The derivative of x to the, I don't know, negative 3/2, it could be fractions too. The exponent comes down, negative 3/2, and we subtract 1 from the exponent. What's 3/2 minus 1? Negative 5/2. Okay. Negative 3/2, we subtract 1, that's 2/2 we're subtracting, so now we have negative 5/2. So this power rule all kind of can be seen in different ways. We'll do more examples in the next videos. I don't know if you've noticed, but section 2.5 is kind of long, all right? I want to spend so much time on this stuff because this is where we introduce the mechanics. We're going to be doing 2.5 for the rest of this entire class, okay? So it's going to be overwhelming at first. There's going to be so many things. That's why we're spending a lot of time so you can get comfortable with it. It'll not be comfortable at the start, but the more and the more that we do this, the more comfortable you'll get, which will be very valuable because now, like by the end of the class, this will be second nature. Exponential functions have nice derivatives. Look, what's the derivative of an exponential function? Itself. Exponential functions are really special when the base is e, Euler's number, 2.71828 blah, blah, blah. The derivative of e to the x is just itself. The slope of e to the x is just whatever the function value is right there. Just kind of cool. And if you have a different base, like, you know, maybe we had 2 to the x or something, a can be any number. So if a is 2, what is the slope of that? It's just the natural log of 2 times 2 to the x. So almost as nice as when it's e, but not quite. If you remember stuff about logarithms, you might remember that the natural log of e is 1. So we really could write this function like this, but because the natural log of e is 1, it's a little redundant. But essentially, it's the same formula. And finally, the slope of the natural log function, just 1 divided by x. That's a weird and kind of surprising one. It's true. We'll talk more about it. And there's a similar formula for any log, but we're really just talking about this specific log formula. So these are your basic formulas. I say basic, take the word basic with a grain of salt. We'll be using these more and getting some practice with them in the next few videos. In the next couple videos. There's only a couple videos in this section. All right. Anyway, take it easy. Let me know if you have questions. And don't fret.